All right, so looking at simplifying rational expressions, let's start first of all with monomials, okay? Simplifying monomial rational expressions.
Wait, are we doing cosines and sines or no? The law?
So, now what we're talking about here really is just reducing fractions, okay? So, as an example, let's say that we've got, let's say a 3x squared y cubed, and that is to the third power over a 6 x to the fourth y squared, which is squared. Okay? So notice on the top there's only one term. It's raised to a power, but there's only one term, so that's a monomial, and same thing on the bottom. But the first thing that we want to do here, before we can reduce anything, is we have to handle those exponents. We have to cube the 3x squared y cubed. We have to square the 6x to the fourth y squared. Okay? So how would we handle this cube, first of all?
Oh, you multiply it by each exponent, and then you'd also do it to the third power. So like 27.
Okay, good. We do 3 to the third, which, you're right, is 27. Okay? And then, Nolan, you said we would multiply the exponents. Okay? So x squared to the third is x to the sixth. Okay? Again, we're doing 2 times the 3, so we've got x to the sixth. And then we're doing y to the 3 times the 3. So that's y to the ninth power. Okay? Now, if you're not sure, or if you can't remember, just remember what cubing something means. It means you're taking something and you're multiplying it by itself, and then you're multiplying it by itself again. Cubing something just means you're making it a factor 3 times. So if you multiply all that together, you have 3, 9, 27. You have x squared times x squared times x squared. You add those exponents, you have x to the sixth. And you have y cubed, cubed, cubed. You add those, you get y to the ninth, okay? This is where that rule of just multiplying the exponents is derived from, okay? But if you can't remember the rule, or you're not 100% positive about the rule, you can always just write it all out. Okay? It's better to be right than fast. Okay? So, now we have the denominator, okay? The denominator, same thing, 6 squared, x to the fourth times 2, x to the 4 times 2 power, y to the 2 times 2 power. So that gives us what as our denominator?
36 x to the 8th y to the 4th.
Okay, 36x to the 8th y to the 4th. Now that those exponents are handled, we don't have any parentheses left or anything, now we can work on reducing this fraction.
But like in the second one, you brought 6 to the second, and then x to the 4
times 2.
and then y to the 2 times 2.
Yes.
Okay.
Yeah, really what you're doing, you're taking this 2 and you're bringing it into each factor here. Mm-hmm. So 6 is squared, x to the fourth is squared, y squared is squared. Okay, so now the last step, we just have to reduce. What is 27 over 36 reduced down to?
9 over, we're not 9, 3 over 4.
Yeah, they have a common factor of 9, so it would be 3/4. So 3 over 4. And then when you reduce your x's, what do you end up with here?
3/4 again.
Well, just the x's. X to the 6th over x to the 8th is,
X 3x to the third. No, the x to the third, x to the fourth, right?
no, you don't reduce the exponents the same way you would coefficients.
Oh, then it would be x to the -2.
Wait.
-2.
X to the -2, okay, and that negative means the x squared would be where?
On the top. X to the negative squared.
Well, x to the -2 means that the x squared would be in the bottom, okay? That's what that's all that negative means, okay? 6 minus 8 is -2, so the x squared is in the denominator. Again, all you're doing here is you've got a fraction with 6 x's on top and 8 x's on the bottom. So that's a 1, that's a 1, that's a 1, that's 1, that's 1, that's 1. So you just have a 1 over x times x. So it's the x squared is on the bottom. Okay?
Oh, it's not. You don't put the negative though.
The negative, I mean, it is x to the -2, but when you're putting it in the denominator,
Oh, okay.
it's not negative anymore. The negative tells you, stick this in the denominator. Okay? How about the y's? Y to the 9th over y to the 4th.
Y to the top.
Y to the 5th, and that's going to be on the top.
Why
Yep.
is it on the top though? Because there's 9 on the top and 4 on the bottom.
Yeah. And if you look at it, look at where more of them are to begin with. There were more x's on the bottom to begin with, so the x's that are left over after you cancel a bunch out are going to be left over on the bottom. There are more y's on the top originally, so when you cancel out the y's, the leftovers are going to be on the top. Okay? All right, so that's simplifying with monomial expressions. Again, just to kind of recap the process. If you have a set of parentheses raised to a power, you need to simplify that first. Once you have everything simplified in the numerator and the denominator, then you can reduce. Okay? All right, so now let's look at simplifying rationals with polynomials.
So the solution for the first one was just like 3y to the 5th over 4x to the 2nd?
That's correct. That's it. That's all you have to do with it. Okay? So rationals with polynomials. Now here, remember a monomial is just a polynomial with one term. Okay? But we could have a mixture of some monomials with maybe binomials or trinomials or any kind of a combination there. So let's start with kind of a simpler one here. Let's say we've got a 6x squared over, let's say we've got a 9x cubed minus 12x. Okay? Now, what do you think we would want to do first here?
Simplify.
Okay? Simplify, do what with the bottom?
Simplify.
Okay, how?
Wouldn't it just be 1x squared over 3x cubed minus 12x and then work it out from there?
Okay, now, so you're wanting to reduce this here, okay?
It's like 2/3, pretty much.
Okay, but here's the thing. When you've got subtraction here, you can't just reduce pieces like this, okay? When it was all multiplication, like on the previous example, then you could just cancel, okay, I see an x cubed and x squared, I cancel them out and I have an x. Alright, but when you see addition or subtraction in there, you can't cancel like you did with the monomials. That's why we're handling this one separate. What can we do with this denominator, however?
You can simplify it, right?
How?
They're all factors of 6, correct? Or 3.
They're all factors of 3, okay? So let's look on the bottom. On the bottom, I could factor out a 3, okay? Because 9 divided by 3 is 3, and 12 divided by 3 is 4.
But you factor out an x too.
Okay? So notice there the 3 was a common factor of the numbers, but notice they both also have x's. So we can take out an x in the denominator as well. If you take an x out of an x cubed, what's left?
2 x's.
Yeah, so it would be x squared. And we took away the x with the 3 from the minus 12x. So over here it's just going to be a minus 4.
So is that the answer?
Well, not yet. Not yet. Now that we have multiplication between that 3x and the parentheses, now we can reduce. Okay, so now you can take that 6 and the 3 and you can cancel and make that a 2. Now you can take this x and cancel it with one of those x's.
So it's 2 over 3x minus 4.
It's 2, and you've got a leftover x the first, over the 3x squared minus 4. Okay? And that's fully simplified. Okay? Now, we can do this with other polynomials as well. Let's say that we had, say, an x squared minus 4 over an x squared plus 6x plus 8. Okay?
Use that.
So here we need to do the same thing. Anytime you see a polynomial and you're trying to reduce here, you want to look to factor, okay? So we're going to look to factor. How would we factor the numerator in this case? You guys remember how to factor these things?
Yeah. It would be the numerator at the top or the bottom.
The top.
How do you do it if there's no number before the x?
X minus 2x plus 2.
That's right, okay? X minus 2 times x plus 2. Here, we're not going to have a common factor like we did back here. Here, there was a common factor of 3x and we pulled it out. This right here, remember if you have two terms and it's subtraction, you can try the difference of two perfect squares, okay? Now the difference of two perfect squares will factor into these two binomials that look alike except for the sign in the middle, okay? The sign in the middle are opposites, so we call these are what are known as conjugates. The reason why they're useful is because if you were to FOIL this back together, you would get x squared. And when you did the outers, the x times the plus 2, you would do a plus 2x. The inners would be a negative 2 times x, so minus 2x. And then the last would be negative 2 times 2, which would be a minus 4. Okay? So you notice here, the outers and inners will cancel each other out, leaving us with just x squared minus 4. Okay? That's why these conjugates are helpful in this case.
Let me do the same thing for the bottom.
Okay? Well, notice in the bottom, it has a middle term. So we have to use a slightly different strategy.
So there's going to be 3 parentheses.
not 3 parentheses. We're still going to do 2 sets of parentheses. But this is where, remember the product sum?
Yeah.
You need, it's an x squared, so it's going to be x and x. All right? But you need 2 numbers that multiply to get 8.
X plus 2, x plus 4 with the number on the outside? No, just x plus 4, x plus 2.
Yeah, x plus 4 and x plus 2 is actually going to work.
Then the x plus 2 cancel out.
Okay, yeah, let's slow down here a second and make sure we've all got this. So it's, they got to multiply to get 8, and they've got to add up to a positive 6. Okay, so you think about your factors of 8. You've got 1 times 8, and you've got 2 times 4. The only one of those that adds up to 6 would be the 2 plus 4 is 6. So that's what we're going to put in the parentheses with our x. Okay? So now we can cancel the x plus 2's like Robbie said. And again, we're allowed to do that because we've changed this from a bunch of things added together to multiplication. There's multiplication there. Once it's multiplication, you can cancel things out. All right? So our final answer in this case here is x minus 2 over x plus 4. Okay?
Can we try another round now?
Yeah. At this point, let's go ahead and look. Well, actually, you know what? Let's try one more thing because I want to put this together here. Okay, the rationals with polynomials. One thing that you'll need to be able to do here is if you have 2 of them and you're doing an operation with them. Okay? So, operations. Let's say that we are dividing 2 of these. Okay, so let's say we've got a 2x squared over.
You flip it and it becomes like multiplication.
You will, yeah. If we're dividing, okay, if you're dividing, let's say we've got x squared minus 9 down here, and we've got an x squared plus 3x up here, okay? You have 2 rational expressions, in other words, 2 fractions that you're dividing, and when you're dividing fractions, you flip it and multiply, okay? Remember, it's keep, change, flip. You keep this one the same, change this to multiplication, flip this one over, okay? That's why you're allowed to just change it to multiplication. So, we have a 2x squared over x squared plus x minus 12 times an x squared minus 9 over x squared plus 3x. Okay? So at this point, notice that first numerator is just a monomial, so there's nothing really to do with it yet. Okay? But the other 3 parts are all more than one term, so we need to factor them. Okay? So let's take this one step at a time and factor them. If I have x squared plus x minus 12, we're going to do that in 2 sets of parentheses. This is your product sum.
Ooh, I think I know this.
Okay? So you're going to have x and x, and what are the numbers that are going to go in there?
-3 and 4.
Negative 3 and positive 4, yeah. Okay?
And then one of the x's in the front is squared, or an x is in front of the parentheses, because there's 3 x's in total. Because the middle term is x.
Well, but here's the thing. You get that. Here you get the x squared. If you were to FOIL this together, that's where the x squared comes from. X times x. The x's in the middle come from your outers, a plus 4x, and your inners, a minus 3x. So 4 minus 3 gives you the 1x. Okay? The only time you'll have an x out in front of the parentheses is if all 3 terms had an x to begin with. Okay? Alright, so let's keep going here. The x squared minus 9, what does that factor into?
3 x plus
Yeah, good. X plus 3 and x minus 3. Difference of squares again. Okay? And then finally the denominator, x squared times x plus 3.
X plus 1, x plus 3.
Is that the fire?
No. Alright, so what is this one? This doesn't have 3 terms, but it's not subtraction, so it can't do difference of squares. How would we factor that one?
X plus 3, x plus 3.
No?
It will be x.
X plus 1x.
Hang on, what?
X plus 3.
It will be x and
Parentheses?
x plus 3.
That's right, okay. Notice they both have an x here, so you can take that x out, and then you have an x plus 3 left over in the parentheses. Okay? Now notice, all of this is multiplication. All the numerators and denominators have all multiplication between those parentheses, and also the two fractions between have multiplication between them. So you can cancel out anything that's the same on the top and the bottom. Alright, so what's something we can cancel?
X plus 3, x minus 3. Oh, wait,
Okay, so
can the x minus 3 that's on the right cancel out the x minus 3 that's on the left?
Okay, so those will cancel. One's on the top, one's on the bottom, they're identical. Alright? What else will cancel? Cancel.
The x plus 3s?
Good, the x plus 3s will cancel. Anything else?
No.
The x out of the 2x squared?
There is an x in this 2x squared, and this x right down here, here. This x right there will cancel out one of those, so now it's just a 2x to the first.
So that
Over x
2x
plus
is
4.
the final answer.
Well, you have a 2x left on the top,
Over x plus 4.
and you have an x plus 4 left over on the bottom.
So would you cancel out
Okay.
the x's? Again?
Well, at this point, notice the bottom,
It's a plus, but.
you've got addition, so you cannot cancel out the x's. Alright, this would just be your final answer. Okay? So that's the kind of stuff that you need to be able to do. Monomials or polynomials with operations. So at this point, let's go ahead and on number 16 through the end on your review sheet,
Do those.
you've got those. So let's take some time and practice working through those, okay?